Okay, perfect. So I hope everyone's here. Some people might be attending or joining a little bit later. I would like to welcome everyone on today's webinar, or shall I say workshop, because today is gonna be more practical than usually. Today we have a special guest, Mr. Paul Clements, a senior engineer at 4D Systems. He is an expert in embedded systems and smart display integration. And today's workshop will be about how to integrate modern display solutions into your ESP32 projects and how you can transform your projects with smart displays. I'm pretty sure that you will enjoy this one. Paul has a really good presentation prepared for you. So without any further doubt, I'm handing over the word to you, Paul, and you're good to go. Welcome again, and have a good workshop, everyone.
Thank you very much. Welcome to the webinar, everyone, and thank you for joining. I will be explaining about our new ESP32 P4 range. In front of you, you will see I've got an ESP32 P4 70CT, which is our 7-inch model, and then we have an ESP32 P4 80CT 8-inch model. Running through the 7-inch, where I got the back exposed, I'll run through some of the interesting parts of the board. Got the ESP32 P4 processor here, and then we also have a 32 GB of flash and an ES sound codec chip. We've got a USB-C connector for programming, a USB-C OTG connector, a 5-volt power connector, and a speaker connector. We also have a 30-way header, which has an available 25 GPIO. And we use this header for, well, you can use this header for connecting peripherals to the GPIO, having full access to the GPIO that's there, or you can use the FC connector and run it to a breakout board or whatever board you make, and all the GPIO is available there. We also have a battery socket and also an SD socket. Also on the board, there is a CSI camera port. I mean, they don't have a demonstration for that at the moment, but that will come in due time. I don't know if you can see this clearly, but this is our Wi-Fi module. Now, this means that you can have the ESP32 P4 display just as a display, an intelligent display, or you can add the Wi-Fi functionality just by plugging it in. This will take up 7 of the available GPIO, leaving 18 left for whatever you need to use it for. So if you move on to our demonstration panel, the 8-inch, on this one I have a speaker connected, which is here. I've got a USB card inserted, which is 32 GB. We can use up to 32 GB SD card. I've got an antenna connected to the Wi-Fi module, which is already plugged into the back. And I've got a keyboard dongle here so that we could use the keyboard. All our models come with an interactive demo that we use for our own product testing, but also it gives the customer something to do when they first switch on the display. So I will now turn on the display, and I'll explain more as we're going along. There's probably a lot to cover in what it can do. So this is what the customer will see the first time they switch the display on. At the top here, there's like a terminal window which will show exactly what is happening. It will also try to detect the Wi-Fi module, and if its Wi-Fi module is there, there are functions that you can do afterwards. On this particular setup, we do have a boot file that we can put on the SD card, and in that boot file we can put credentials for connecting to an access point and various other things, which I'll explain later on. But the customer doesn't need to do that. This demo is interactive, so there's things that they can do without having that boot in file there. So when we come on to the landing page, we give a description of what this particular model is. It's an ESP32 P4 80CT. And we have a main volume control here. And we also have a screen brightness control, which we can adjust. In addition, we have a panel here, which is like a bit of a status bar, and it will show what the touch X and touch Y coordinates are, and also how long the demo has been running. So, first of all, if we go through the buttons one by one, the various options that you can do with this interactive demo, if we press on the touch button, it will open up to a simple drawing kind of program where we can change the color of the pen, change the style of what we want to draw, change the thickness, and we can just generally draw things on the screen. It can be very creative or not very creative. I'm not. Change that to a line, thicker, blurred line. And there's many things you can do. But that is like a simple touch test that we use in production, but it's also a little bit something the customer can use. So that's like a simple touch test, and it's a good way of actually proving that everything works. The next button we have is media button. Now I've got a 32 gigabyte SD card, and it will scan the SD card looking for media. It's looking for MP3 files and MJPEG files. And then it will give you a series of buttons at the bottom. If there is no SD card there, you can do a sound test by using built-in samples. If I press this button here, it just plays a sample that's in memory. I don't know if you can hear that well. And then there's just 4 samples there. So on the SD card, it did find some music, so I could press the play button. And there's playing an MP3 file. It also found MJPEG, so if I press the play video button, it will go through and play videos it finds. It will do this. MP3s will play in the background quite nicely. And then this is one which is found an MJPEG and an MP3 file as well. So again, these things, say if the customer did put these on the SD card, they have got something to try. They could, a little bit of entertainment. And then we can stop. You'll notice in the taskbar, there is an MP3 transport panel. And here I have a volume control and play, stop, pause buttons as you were getting a normal MP3 player. That will remain there now because it's actually found media. We can do an SDMMC test, which is testing the SD card. Again, more buttons will appear at the bottom for various tests. We can run all I/O tests. It's a simple way of doing it. And that is completed. It gives you a rundown of the speed, read and write speeds. We can also do it DIR of everything that's on the SD card. Next, we have a graphics demo. Now, a lot of these graphics demos are done to sort of show what the display can do. When we were creating the library, the GFX4D ESP32 P4 library, we did take on board all the hardware features that the ESP32 P4 offers. So everything that we do graphically, we do use all the hardware acceleration that's available. One of the demos makes a good point of how you could have a project on a previous display that would be compatible, say like on an ESP32 S3 display, and that would be fully compatible to run on the P4. But there may be changes in resolution and screen size and everything else, but it just kind of show what you can do using the hardware acceleration features to make that project run without changing too much. But what we'll do is we'll go to the first demo, which is a demo which is created in Workshop 4. And we have various graphics assets, simple buttons, and a rotary control. And these are all things that can create in Workshop 4 very easily, which I will show you later on. Next, we go to the next demo. It's not there for fun. This is an old piece of code from our very first expressive display. And when I was explaining about how you can make a program run from an earlier backwards compatible and make it run on the P4, this is actually a 320 by 240 program that was on our first Gen 4 IOD range of displays. To get it to run, it was a simple case of using the hardware acceleration to scale and rotate it. And it does all of that without any slowdown. And it works very, very efficiently. The next demo is an LVGL demo running inside our software as a windowed application. It works just as normally as it would do on any ESP32 display. And it runs very well. The reason we're showing you this is that a lot of people do use LVGL. And there are, because you could run this alongside our code within our Workshop 4 as a separate project, you could window it, or you could use some of the features that we do have, because we recently introduced a canvas buffer where we can move this whole canvas around. So there are things you could do, and it wouldn't be a case of, oh yes, we're going to use LVGL and LVGL only. You could use LVGL and take advantage of what we offer in Workshop 4 at the same time. And as you can see, it works very well and there's no slowdown. Because we have a Wi-Fi module connected, we can do the Wi-Fi test. Now, we have simple scan tests. Say if you didn't have an SD card and a boot file created, you could just press the scan button and then it will do a scan of all available access points. But because we have got an int file created, so on some of the one of the entries that you can put is for internet radio. Sorry, it's a bit loud. So that's streaming internet radio over the Wi-Fi module, which it does extremely well. In addition to that, we also have some webcams. The first one is from a laptop webcam, which is not live at the moment. And that is a webcam from somewhere in Europe. I don't know where. But as you can see, the frame rate is very, very good. And this is with the connected Wi-Fi module, which is an ESP32 C6, by the way. I didn't explain that earlier. And then there's another one, which is the Netherlands, if I'm correct. So let me turn that radio on. So as you can see there, we're streaming audio and streaming video all very well. And in a way, because it is an attached device and it's not sharing resources as much, everything seems to work a lot smoother. We were a bit concerned at the time of having an attached device and how well it would perform when it comes to getting data off the internet, but as you can see, it works very, very well. So we will leave that demo running at the moment, and what we'll do is we will do a simple workshop 4 project. Anybody who knows the ESP32 will know that the compile time, especially the first one, takes a bit of time. So what we'll do is we'll do a simplistic project, and we will compile it and show it running on the screen. And then hopefully we might be able to take some questions during that time. So bear with me while I change screen. Okay, I hope you can all see that. Okay. Now, I have already opened the workshop 4, and I've already chosen this particular display model, the ESP32 AT, which you will see at the top, and it's in a portrait mode. Now, if I explain a bit about some of the features, this is our home tab, where we can open, save, normal file operations. We have a bit of normal clipboard, undo, redo, find and replace. So this is where we go for our majority of things. And at the very end, you'll see a compile and load button, which is what we use at the very end to compile the project and then flash it to display. On the left here, in the text window, this is where we enter our code. And as you'll all see, it's familiar Arduino code that we use. This will actually generate Arduino code, which we would then use the Arduino IDE to compile it in the background and then flash it to this display, all done by one button. This part of code is generated automatically when you open a new project and start using and choose the display. It will automatically fill up the code with enough to get the screen going, and automated code for any inputs or widgets that you add. We have a Tools tab, which provides a terminal that you would be able to access through our 4D UPA, which would connect to the FFC connector on the board. It's handy for debugging and things like that. And this is our widgets tab. Starting with the backgrounds first, we have border, gradient, and a scale that you can just put on your desktop. Say like if you were doing a graph, you could automatically generate a scale. Buttons. We have our own nice gradient button that you can put on the screen. And we have a user button where you could create an up button, a down button, and that gets animated automatically. These are preset buttons that you could use, and some toggle switches at the end. We also have some digits. This one is like an LED digit. This one is what we call custom digits, where you could design your own digits in the form of a bitmap and then load that in, and then Workshop 4 will automatically generate the right spacing and enable you to design your own LED digits or anything else that you require. This one is a simple LED, and this one is a bigger LED. We have some gauges in the gauges tab. This one is an angular meter, a gauge, vertical, horizontal gauge. Sorry, this is our angular meter. This one is a different meter. I apologize. This is our cool gauge, which is a very complicated gauge, which you have a lot of parameters that you can set to make it look the way you want. A thermometer, a tank, and a spectrum. This one here is a smart gauge, which I'll explain in more detail later on. There's a reason for that, and you will notice that it is present. It didn't used to be present in this IDE unless you did buy a license, but I will explain that in more detail. This is the input section. We have a knob, two types, and a rotary switch, a slider, a trackbar, a full keyboard, which you can edit the way you would like, a dip switch, a rocker switch, a color picker, and again, these are smart inputs. It's a smart rotary and a smart slider. Again, I will explain that in a bit more detail later. Then we have a simple label. This is text that you would create on here. You can pick at any font you want that you have on your system and whatever size you want, and then that will be stored in memory as an image. And then we have some primitive drawing widgets. They can either be done here or can just entered in code directly. And then we have system media. Now, say if we want to display an image, we would just click on that, and then we would put the image on our display, whatever you like it, and then pick the source data, and then that image can be displayed when you like. We have a video icon, a form icon. You can create forms, separate pages. And you can then switch these forms in and out, which would be a whole list of different widgets. We also have a user images function where you could custom design a load of images, a lot of an animation, and you again would place that on the desktop, and then you can show that frame by frame. And then we also have an inherent font widget. The inherent font widget will allow you to choose any font that you have on your system, and then that will get stored into memory, and then you can use that font as normal text. Say like if you use the print function, you could just print that text anywhere you want it. So if we go back to home and we start making our project. Now, as I said, because of the compile time, that we will do a very simple project to start with. So we'll go to our widgets tab, and we will choose the cool gauge and place that in our object inspector. We can resize this to whatever we want. I think that's good enough for now. And then we could put some digits over here. Again, you can resize these to however looks best. Now, this gives us the opportunity to make some changes to our widgets. I'll just move that up a bit so we can see the object inspector. Now we can change the amount of digits that we want. We can change that to 3 because we're only going to count from 0 to 100. Get rid of the decimal point because it's going to be a whole number that we're showing anyway. We can change the color. Just simply pick a color, and then we'll leave it at green for now. If we go back to the cool gauge, you'll see there's an awful lot of options that you can change to make that look the way you want it. But we won't do that now because there's quite a lot of options there. Right, so to make all this work, it would be good for us to have an input. So if we go to the input widget and then pick a slider and put the slider around about here somewhere. Now we can change this from vertical to horizontal orientation. Just put that up there, make it a bit bigger. It's a bigger screen. Right, so we have our very simple GUI made. When it comes to actually programming the widgets, you don't really have to think about it that much. It's not a task at all. What we do is you will find that there is a paste static code button, and this will paste all the code necessary for that widget. But it'll do in such a way where, say it was an input widget, it will do all the code for the input to actually work. So if we make a space here at the bottom of our setup routine and then paste static code, it's already pasted in code for this widget. If you notice here, it says GFX image touch enable, which enables the slider to be touched. And then it will show the slider once at its default position. And then if you go down to our main loop, you'll notice it's already inserted code and what to do with the slider that we have chosen. I just noticed there it says horizontal slider, and then it has various parameters, and this is usually for the gap at the end, at the beginning, at the end of the slider, just so that when you do touch it, your finger is in the right place and the slider works correctly. So that will return a value of what that slider does. So if we go back up again to our code, make another space here, click in there, click on our cool gauge, and then paste static code. It will give us 2 bits of code for that one particular widget. One is what it displays initially, which is the cool gauge at position 0. And then it will give us this code, which we can copy, delete it, and then put it into our slider touch routine and change the variable to val. So now what we've done is that when the input widget is selected or moved, that the variable val will change, and then that variable is then used in the user images command to change that to the value of the slider. Going back up here again, we've got space here. I'll click in there. We can do the same thing again for the digits. We can paste static code. And again, you will see another line that we need to copy. And then put in our touch code. Again, setting the variable name to val, so it will directly respond to whatever the slider has returned. So that is essentially our code done. Now, there are various options as to where and how we can save this image data. We can use the internal flash, we can use the SD card, we can even load in the graphics data from the SD card to PS RAM if that's a scenario that is needed. So what we'll do is we'll go to the project and we will click on this option here, do a right click on this option here, and this will open up our Arduino settings for this particular display. You'll notice here we have our Arduino options. If we scroll down to the bottom, we'll find our board there. And then we can right click on that. What we're doing here is we're making sure the partition, because we're going to save this directly to flash, we're going to make sure the partition is big enough to take all the graphics data and the program data. So we're just going to change the partition data to the largest. And then we can click on our ESP32 file options. By default, it is set in the compatible mode. So say if you had an ESP32 S3 project and you were porting over to this one, it would have been in that format. But as things have changed anyway, you could have an ESP32 S3 project which carries the same kind of options as this does. But generally it's set up so that all graphics elements are put on the SD card, they're not compressed, and the SD card requires to be inserted into the PC to have the data transferred to it. What we're going to do in this one, we're going to use a compressed format. Because we're going to put it into flash, it would be best to make this as small as we possibly could. So we're going to select the GCJ format, which is JPEG. JPEG decoder on the ESP32 P4 is a hardware decoder, and it does this very, very well. And then we have a destination for our graphics. It's selected at the moment for USD, but we're going to put it in program flash. Because we've done this, there's some things we have to change in the code that we created earlier. What we'll do is we'll save this and give it a name, which we'll call SOS electronic for the systems. And then save it. Now you'll notice the code has changed to reflect the fact that we've saved it. The file name is here for a constant file that is automatically generated, and also here for the GCJ, which is the graphics file that is going to be loaded in to show the graphics on the screen. Now, because we have selected that we're going to do it from flash, what we call the GCX file has been created. So we need to uncomment that now, so we can include the graphics onto flash. And then we also need to change our open4D-GFX command to open from flash. And it has the flash data pointer name and also the size. So I'm just going to check everything over and make sure we haven't got any errors in code. And then we can compile it. But as I said, anybody who's used the ESP32 will know that the first compile can take quite a while. Obviously, if the PC is a good PC, it will take quite a bit less time, but we're going to click on compile and load. Oh, sorry, before we do that, we need to pick a COM port where the display is connected to. I happen to know this one is COM38. So I pick COM38. Sorry, I could have missed that step. If you miss that step, you'll get a warning to say that there isn't a port. It's not connected, so it's not a big deal if you forget to do it. And then we can click on compile and load and hope for the best. At the moment, you can see in the desktop that it's generating all the graphics files ready to create that graphics H file. And now it's doing a compile process, which you can see here. So we have a bit of time while it does this. What I was explaining earlier about the smart widgets, Workshop 4 used to come in two different types. There was Workshop 4, which was the unlicensed type, and Workshop 4, which was the Pro version, which was a licensed type. Since about a month, we have dropped the fee for the licensed version of Workshop 4. So all Workshop 4 downloads now are Workshop 4 Pro. On the ESP32 P4 device, it allows us to use the smart widgets function. And the smart widgets function is it's an application where you can you can create your own widgets, and you can create your own widgets by, say, in terms of selling, we'll say a simple gauge, where you could have the background of a gauge, which you create as one image, and then you can have a needle, which you create as one image. And then you can use the smart widgets editor to animate the needle moving around the gauge. Becomes very useful in that aspect. You can also do smart inputs, smart sliders, vertical gauges, even complex gauges. You know, like when we talk about aviation gauges, it's even possible to do that with multiple needles. So it's a very easy to use editor, because of the fact you are not having to make a load of images yourself. You are just animating the various elements. In addition to that, you can use the smart widget editor to create digits as well. So you could have a really large font, fancy font of your choosing, and you can just use it for creating a nice set of digits. It compiled faster than we thought, which is good. So I'm going to switch back now to our window, and we should see this come to life with what we've just created. And then if I turn on this, go to the slider, move the slider up and down, you can see how easy it was just to make that one project. Now, obviously, you can embellish this. The GFX4D P4 ESP32 P4 library has many other features as well. And from a coding aspect, there's a lot more that you can do. On top of, you can create your GUI here, and then there's various functions for doing various things. Everything that we've done when it comes to drawing shapes, lines, things like that, everything is anti-aliased. So you can create this really nice GUI, as you saw in the demo that was first running. I hope I haven't missed anything out. That time went really, really fast. But I am good now if we want to switch to questions.
Perfect. Thank you all for whole presentation. I've seen that we had a few of them in the chat, and I can just share them on the screen, and you can just feel free to answer them if it's okay for you.
Yeah. Okay.
Okay, so can you see the screen, Paul?
I can, yes.
Yeah.
Right, okay. So I was just reading the one about one that didn't see the presentation itself with the program, but that was okay.
Yeah.
Right. The first question I've come across here is display Wi-Fi compliant with red? I will find out with that, and I will get back to that question in the chat if that's okay. Does Workshop run under Linux? Unfortunately, no. It's a Windows-only application. It can be run in a VM, but no, it's a Windows application. What ID is this? This is our Workshop 4 IDE. This is what we use for all our products, and it's a free IDE which you can get from our website. Okay, that's been answered already. Thank you. The JPEG hardware acceleration is only available in the ESP32 P4. We also have the ESP32 S3 display module, and on that one we do use the software JPEG decoder, which is really quite good. It does allow us to put more graphics elements into Flash if you didn't want to use a USD card. But yes, the hardware acceleration is only available on the ESP32 P4. The PPA accelerator is quite spectacular. The way that operates, it's amazing. It's amazing that if you take into consideration that it's a PSRAM device. I know this probably comes from experience with the ESP32 S3, where the PSRAM is fast, but there seems to be something a little bit better about the P4. So when it comes to using the PPA acceleration features, which is all done in PSRAM, it is quite mind-blowing at how fast it does these tasks. Okay, is there any more questions?
Okay. Already answered. So we can wait 1 minute more if anything will pop up. But
yeah,
if you
do you think it'd be a good idea to show the pro features of Workshop 4? You know, we touched on it earlier about the license becoming free, and then we said that we could possibly fit that in. It's possible we could do that now.
Sure. Yeah, go ahead.
I will switch back to my desktop again. Okay, we talked earlier about smart widgets in the pro version of Workshop 4, which is now free. I think probably the best way to explain this is to actually do something. So this slider, we'll get rid of this slider, and we will click on the widgets tab, and then click on a smart slider. Again, we want to put the slider around about here. And then we have, if we go down into the object inspector, you will find a config tab. What we'll do is we'll set the orientation to horizontal first. And then we'll click on the config tab. And this will open up our smart widgets editor. Now, I don't have any pre-prepared images that we can do this, but we do have some already, which I can load in from previous examples. And then I will be able to show you how the layers work. So I'll go ahead and load in a slider. So as you can see, we have this very nice slider, which gets put in the position that we were actually in before we went to the config. If you look at the top here, you've got layers tab. Now, layer 1, if I disable layer 1, you'll be able to see that the knob of the slider has disappeared, because that's a separate layer. And then we disable layer 2, we get rid of the mask which goes on top of this colored bar here. And layer 3, if we disable it, we'll get rid of it completely. So these are all the layers that are made up. And we also have the top layer, which is the mask, the metallized background, which is shown over here by clicking that one. But if I go back and enable them all again, all the layers show off. So this what this will do is it will generate a whole series of graphics files. So this can be really complex graphics files that you can just load in, and then you can manipulate them by setting what it does within the minimum maximum values that you're going to do. In our case, it's from 1 to 101, frame 100 to 101. And if I go ahead and move that across, you can see exactly what this is going to do. So these are all layers that are put down, and they all get generated into one single graphics file. So if we go ahead and click OK, we now have our slider there. So we created slider code earlier on for the previous slider. So what we'll do now is we need to use the paste code button again. So we'll click in there and paste static code. Now you will see that it's put in the code for our smart slider and shows it once. And then it's also created a smart slider function that we can edit. So what we'll do is we'll take out the code that we generated earlier, and we'll change that over from slider 1 to our smart slider function, and get rid of the case for the slider 1 because it no longer exists. And then go up here and then get rid of our code for the previous slider. Now going back and make sure I've got no errors again. No, everything looks good. And then we can click on home and then compile and load again. Again, you can see it generating all the graphics files. Compile the second time round is an awful lot faster. It's a very, very minimal change to the Arduino code. Most of the changes was in graphics data. It gets done automatically. So hopefully this won't take long at all. It also depends on the size of the project. I mean, if it's a huge project, you know, like the interactive demo that we had shown earlier, first compiler, that can take quite a long time. But it's one of the things with an ESP32. As you can see, that didn't take long at all. And now it's just loading the new data to the display. Which is actually taking longer than the compile this time. So I will switch back now to my desktop and to the camera. And there it is with the slider that we just created. So again, the smart editor is very powerful. It is quite hard to generate image sets. You know, when it comes to doing gauges, circular gauges, do a whole image set and create that many files. It is quite a process. But this takes out that work. It's just this one background image and this one needle, or in the case of this slider, foreground, the colored bar, the mask, and the knob. So it's just 4 images, and it makes the task a lot easier. No, it doesn't. I just noticed a question now. It deleted the old slider. Shouldn't IDE remove also source code for the slider automatically? Well, yes and no. It's only a minor thing. When it comes to the graphics elements, anything that was there before, obviously that gets removed. It's regenerated as new graphics, so there is no sort of like wasted space in the graphics file. They're removing the code for the slider because I'd already altered it in any case by adding functions for that case. Not really a practical thing to do. Okay. So as I said, that is one of the that is a new feature in the Workshop 4 IDE, which is now totally free, which is quite a bonus moving forward in the displays. It does take on, it works well with the ESP32 P4 being a larger display, larger resolution. So the creative, you can be very creative with the minimum amount of work.
Okay, Paul. So thank you for this extra slot to today's webinar. It was really good that we had time for this as well. Thank you for also for answering the questions. And if any other questions occur, feel free to contact our sales guys, and we'll give you then a answer straight away. The recording of this webinar, so the whole workshop that Paul just showed you, will be available on our socials. So if you guys would like to check it out again, send it somewhere you can use it, and so keep up for that. So Paul, thank you very much for joining us today. It was a pleasure hearing you and watching your mastery at work, and hopefully we can do this again sometime.
Yes, I would look forward to that. I will be less nervous next time.
Perfect. Okay, Paul. So thank you again. Wish you all a nice and successful rest of the day, and see you again at the next webinar. Thank you,
everyone.
Bye.
Thank you.
Bye.
Bye-bye.